What's up, everyone? Vin here, and this is the 2026 Algebra 1 live stream review. So, just looking here at the chat. So, we have some people here right now. So, hello. So, yeah, I'm going to go through the January 2016 Algebra 1 Regents. That's the one. Yeah, I'm just going to do the whole Regents for this live stream. I did move this to an earlier time because I just felt like 8 o'clock was a late start, especially that the test tomorrow is at 9:15 in the morning. So, yeah, just wanted to be on here. But hello to everyone here. And, yeah, I'll get rolling here. So, let's see. It is, well, it's not 5 o'clock yet. So, I guess I'll wait till exactly 5 to get this going so that it's not false advertising. All right, now it is 5. So, I guess I could start. So, once again, I'm doing January 2016. Now, I believe there's one question here that I'll just say throw away because it's outdated. They don't cover this topic anymore. Something called residual values. But, yeah, that's what I'll be doing. All right, so part 1, 24 questions, multiple choice. And they are 2 points each. So we have f of x is a quadratic function, and we want to find the minimum value. Or we want to find when does the minimum value occur. So the x value here. Now for this one, there's a few different things you could know. So if you want the concept, this is the concept. So vertex form. So what I'm seeing here is, okay, the vertex is HK. So here, our vertex would be at positive 2, comma 4. And since we have see how here like our a value is equal to 1 and 1 is greater than 0, it's going to be one of those smiling parabolas. So 2, 4, smiling parabola like this. So the minimum value is going to occur when x is equal to 2. Okay, so that's like concept-wise how you would do this. But if you're like, wait a minute, I just want to get the credit. Oh, can't see the question. Thank you. Let me, I think I know what's going on. I'm going to have to re-add the, you know why I should, OBS I just opened, but I think it's like, I'm just going to refresh the screen capture. So thank you. Yeah. So hang on. I'm going to fix it. I see the chat now. Thank you. Well, good thing for 2 monitors. So hang on 1 second. Let me just I'll just remove the screen capture and then I'll re-edit. It should be fine though. Hang on. Screen capture. Sorry, technical difficulties. We'll be fine though. I'll get it back up and running. All right, cool. So this, and let's see. So now I got to resize. Let's see. So screen capture. Yep, that'll do it. All right, here we go. And all right, we can see it now. Yeah, let me know. Cool. Oh, this is the one I'm doing. I know, like, oh, can I do a recent one? So at Selena, I have like all the recent ones are like on YouTube. So I would say I've gone like within like the last maybe even 5 years or more at this point. But you know, any recent Regents, you could just watch. Like, I have like full videos covering them from like from part 1 all the way through part 4. All right. So yeah, once again, the concept was this formula here. So vertex form, and I identified the h and k value here as 2 and 4. So the vertex is at 2, 4. Parabola is opening upwards, so it's this. But now, how do I do this with the calculator? So y equals, and I just type in the function. So I have parentheses x minus 2 squared, and then plus 4. So I do this, I press graph, and I could see the minimum is occurring here. Even if you press second graph and go to the table, see the minimum value is at 2, 4. You could also press second trace minimum, and then you go to the vertex, the turning point, you press enter to the left, and you press enter to the right. And press enter a third time and 2, 4. All right, so there's a lot of ways you could get that maximum, but that happens when x is 2. All right, cool. So the next one is reading a graph and identifying it looks like the rate of change here. So Let's just see. So let's go with, all right. So the graph below was created by an employee at a gas station, and it's cost of gas and number of gallons sold. So which statement can be justified by using the graph? So for this one here, if we look, let's see, if 10 gallons are purchased, $35 was paid. So this one is not going to be the answer here because, see, that would mean like 10 gallons purchased, it would be lining up at 35, but this is like 37 and a half. So not quite there. For every gallon of gas purchased, $3.75 was paid. So this one here, the big idea is this is linear. So this has a constant rate of change. So then what I could do is I could find the slope, and notice how, see how like 0, 0 is here? So I could find the slope between two like well-defined points. So here, this is the point 4, 15. So the slope is equal to 15 minus 0 over 4 minus 0. And then this would give us 3.75. If you do 15 divided by 4, that gives you a slope of 3.75. Okay, so, and remember, it's rise over run. So this is going to be, the units are going to be dollars per gallon. So for every gallon of gas purchased, $3.75 was paid. Choice 2. Okay? Cool. All right. So let's see, moving on. Okay. So next up, question 3. We have, for a recently released movie, the function y equals, so this function here is exponential, models the revenue earned, y is in millions of dollars each week, x for several weeks after its release. Based on the equation, how much more money in millions of dollars was earned in revenue for week 3 than for week 5? So for this, I would just make a table of values and see what's going on at week 3 and week 5, and then just subtract these two. So these I would subtract. Okay, so that's what I'm going to do. Okay, so this one, I just have the function I'm going to type in. So this is really just calculator skills. So y equals 119. Oh, they said it, 67. This was before that craze. Okay, 0.61 and to the x power. Great. And now we want to know what's going on at year 3 and year 5. Or I'm sorry, week. It was weeks, right? Yeah, week 3, week 5. So you could just copy this value down and then copy this value down. Like, that's fine if you do that. But, yeah, so how about we remember these values here? And we're rounding to the nearest hundredth, it looks like. All the answer choices are in hundredths. So week 3 versus week 5, if I subtract, let's see, 27.163 minus 10.107. So 27.163 minus, don't get old, 10.107. Okay, 10.107. And you get 17.056, which rounds to 17.06. Okay, so 17.06. This one. I'm going to show you another magic trick. So you ready? More magic. So calculator magic. You could also, for this, so let's see. All right. Oh, yeah, just to show you. So I subtracted the function values at 3 and 5. If I do second trace, well, hang on. Alpha trace y1 of 5 minus alpha trace y1 of 3 and press enter, the value decreased here, but you see you still get 17.06. So that's like doing f of 5 minus f of 3. Okay. Cool. All right. Let's see. Oh, there seems to be some... Wait, a few people are... Yeah, so hang on. You know, I'll do this for everyone. I'm not going to change Regents, but there seems to be a little buzz about like which regions people want to see. So this is what I will share in the chat. If you're wanting to see the the recent regions, since that's like seems to be the buzz right now, I will share the playlist where I have going all the way back to 2021. Okay, so whatever Algebra 1 regions you would like to see. So hang on, let me just throw this in the chat. Here, there it is. Okay, there's a playlist. Cool. So you could watch those if you're like, hey, 2016 was... I saw someone said, you know, LeBron being on the Cavs. Yeah, way back when. Okay, great. So now I will continue on. So if we have these expressions, which ones result in an irrational number? So irrational, well, this one here is not going to be it because these are both rational numbers. Okay, anytime you could write a number as a fraction, like let's say p over q, and p and q are integers, that makes the number rational. So this would be rational. This one, square root 5 times square root 5 would be square root of 5 times 5. And square root of 25 is equal to 5, which is a whole number, so is rational. This is equal to 3 times the square root of 49 is 7. So that makes 21. Rational, so it's really just 2 only. A rational plus an irrational is irrational. Okay, so Roman numeral 2 only. All right? Cool. All right, moving on to the next topic. Okay. Oh, wait, hang on a sec. So, all right, cool. So looking at the next question here, we have which inequality is represented by the graph below. So we have a linear function here. And if you remember y equals mx plus b, m is the slope and b is the y-intercept. Okay, and for slope, I just think slope, a little extra, I say rise over run. So here, b, the y-intercept, for this one is -3. And then the slope, see I'm rising 2 and running 1, going up 2 over 1. So this one has a slope of 2 and a y-intercept of -3. So the 2x minus 3 is already like our top option. So it's y something and then 2x minus 3. But notice solid line, so it's definitely going to have an equal to. And this is shaded above. So it'd be y greater than or equal to. Choice 2. Okay. Awesome. So that's that one. 5 should be choice 2. Oh, in the chat. Yeah, I'm happy that the Algebra 2 live helped a lot. So, yeah, I'm glad. That's good to hear that the Algebra 2. Yeah, I live stream for Algebra 1, Geometry, Algebra 2, and then the AP Calculus exam. So those are like my main subjects that I prepare people for. But I'm glad it helped. That's why I do these. I just want to be able to help people. What does it say? Oh, say 6-7. Yeah, 6-7. Right. I don't know. I don't think that ever will go out of style. Something's telling me that one's here to stay. Like it's gonna get quiet for a while, but then it'll be back. So, all right. Mike borrows money from his uncle, who's charging him interest. Wow. I don't know how I feel about that. Good uncle or not. I don't know. But that's not the point. The point is to solve for r. Okay, so find what r equals. Okay, so solve for r. So we divide both sides by p times t, because it's all multiplication. P times r times t. And the opposite of multiplying is dividing. So divide both sides by pt. P divided by p cancels. T over t cancels. And now r equals I over p times t. Choice 3. The Algebra 2 was also old. I might have did 2016 for that also. I can't remember. After a certain age, it's hard to remember stuff. But, all right. So let's see. We have... Oh, yeah, which equation is equivalent to this? So this one is... I mean, you could just use the calculator for this. Is that exciting? Or is there another way? Oh, I know. All right, so this... All right, so calculator if you want. Or you could complete the square. Which one's better? How about we... All right, algebra first. Since this isn't Algebra Regents, I would be neglecting you if I didn't show you how to do the algebra. So I distribute. And now completing the square. Everyone's favorite. All right, this topic is a little tough. So completing the square, when you have like 1x squared and then an x term, you take the term in front of x, the coefficient. In this case, negative 12. You divide by 2 and then square it. Negative 6 squared is 36. And that's the mystery number that I add to both sides. See, I add this to both sides. The reason why they call it completing the square is that this turns into what we call a perfect square trinomial. So when I look for two numbers now that have a sum of negative 12 and a product of 36, like we're going to factor this now, so that's just a product. Then we get x minus 6 times x minus 6. And then on the left side, we get y plus 2. And then I could just say this is y plus 2 equals x minus 6 times itself is x minus 6 squared. And then just go minus 2 on both sides. Okay, and after we subtract 2 on both sides, this one does work out to choice 4. Okay, just double checking that everything worked out nice. So we get x minus 6 squared minus 2. So this is if you're like, hey, I want to do this with algebra. If you don't care about doing the algebra, you're like, hey, I just want to pass this. You still got to move this. You still got to solve for y. Unless you had Desmos, then you could like... Desmos is really like game breaking for exams. And you could use it on the SAT and AP exams, but not every school is like Desmos activated for the Regents. So x times x minus 12 plus 34. So just remember this. All right, so we remember that. We solve for y. And let's see. We solve for y. So I got y equals x times x minus 12 plus 34. And I'm claiming the answer is 4. So I write the other form here. X minus 6 squared and then minus 2. And if I graph both, see how they overlap completely? So that's definitely the answer. If I put in one of the wrong answers, like let's say I put choice 3, which is like almost right, but you can't be almost right in math. And I make it a plus 2. See how they don't overlap? So that's how I know 3 is out. So choice 4 is definitely good. All right. Oh yeah, go Knicks, right? New York people. I should watch more sports, but I don't. I used to watch sports back in the day. I do watch like MMA, like UFC. I watch, but I feel bad watching it sometimes if someone loses really bad because, you know, CTE, like they take a bad loss. It's like, you know, brain damage and stuff, which is you just feel bad for them as a person. You don't want to see them get hurt and stuff. But it's an impressive skill. But all right, cool. So the equation here. Someone said, I'm stressing. How do I stay calm and feel ready? So just so you all know, talking directly, to the camera, that is part of like basically every test that you're going to take. Like being nervous, scared means like, I think it means you care. You want to do well. It's normal. Any sort of competition that you're going to have, whether it be a test or sports, like you're going to feel some level of nerves before it starts. But the best thing you could do is just what you're doing right now is preparing. Like you're on YouTube watching a review and trying to get ready for this. So you practice. And I used to tell myself, like, even though I was nervous before a test, I would say, all right, well, I put in this many hours. So now I'm just going to show up and do my best. Like, really, that's all you have control over is like how much you prepare for this. You know, and just hope it's not as bad as like physics or chemistry was, right? Anyone take chemistry? I know that one was a little rough. But yeah, but I'm rooting for you all. I hope everyone here does well. All right, let's see. So now back to, if you completely blank out, that's normal. That happens. You just tell yourself like, hey, I already learned all this. Like it will come back to you. All right. Like your memory system like is there. Like if you could remember like a past birthday or something, it's like your brain works. Like you can retain information. It's just, it's not going to come to you right away. Like math is not always about like having like all 10 steps down at the first, like, you know, glance of the question. Sometimes you got to like, oh, I tried this and it failed. Oh, let me try this. That failed. Oh, the third thing worked. Problem is some kids, they try the first thing and then like they panic and they're like, oh, I don't know what to do. And then they just guess and move on. Like sometimes you got to stay with it. I can't tell you how many times a kid will say in class, like, I don't know what to do. And then like I start walking over and they're like, oh, wait, never mind. Like it just came to me. It's like, yeah, like you got to train yourself to like sit with it and be confused more. If you don't know, if you genuinely don't know anything, like if we just grabbed like a random, you know, like fifth grader and was like, here, kid, you're going to take the Algebra 1 Regents. Like, sure, they have every right to panic because they have no idea what they're doing. But if you sat through the class, like you did all the homeworks and stuff, then yeah. Yes, the calculator is magic. So be good at the calculator. But it won't like do the whole Regents for you. But it is useful, like in certain situations. Like question 9 for sure is all calculator. All right. So back to this. So here's this is being used to calculate the amount of money in a savings account. What does this represent? Okay, so here we have to think about this formula. A equals P times 1 plus R to the power T. So if we look, 1.02 would be equal to the 1 plus R part, which if I subtract 1 on both sides, which I'll call 1.00, this is 0.02 equals R. And 0.02 is 2/100ths, which tells us R is 2 out of 100 is 2%. So that is a 2% growth rate. Okay, so 2% growth is choice 4. Okay, not 0.02%. 0.02% is 0.02 over 100, which would be 0. And then like 3 zeros. Wait, yeah, like 2. Yeah, 3 zeros and then a 2. So not that. That would be like not enough zeros or too many zeros inside. So not that. So definitely 4. All right, question 9, like I was saying, is all calculator magic. So you could just go y equals and to x squared minus 4x minus 6. Graph, and we have roots at -1 and +3. Or 3 and -1. They wrote first. So 9 is choice 1. Okay, so you just graph zeros of a function where the roots are where the graph hits the x-axis. So it's very clear that it's going to be here and here. All right, so that's one way. If you're like, all right, what about, like, how do I do the algebra? This is the algebra Regents. Like, I want to know how to do the algebra. Then for this, I would first take out the greatest common factor is 2. And then the math that I'm doing in my head, if I'm doing this, you know, algebraically, is I'm dividing everything by 2. Like that's what happens when you factor. You divide everything by that factor that you're taking out. And we have x squared minus 2x minus 3. And we want to find the zeros. So we set all of this equal to 0. And now we factor. So we need two numbers that have a sum of -2. And they also have to have a product of -3. And this would tell us 2 times, and we would have x minus 3 times x plus 1. And these are the factors because -3 plus 1 is -2, and the product of those two is -3. So that's why that works. and then you just set each of these factors equal to 0. Don't actually like set this equal to 0. Don't say, oh, 2 equals 0, because that's just obviously wrong. So you're not going to get an answer from that. But you can say x minus 3 equals 0. And that's true when x is 3. And x plus 1 equals 0 is true when x is negative 1. So 3 and negative 1. All right, 10 is another example of calculator. But this I'll show algebra first, and then I'll show calculator magic. So when this is subtracted from 5x squared, so we're doing 5x squared minus 2x minus 3 squared. For something like this, I recommend you go on a side quest. Okay, side quest. So on the side quest, I'm doing 2x minus 3 times 2x minus 3. 2x times 2x is 4x squared. 2x times minus 3 is minus 6x. This makes the same thing. And then minus 3 times minus 3 is plus 9. So algebra first, and then I'll show the calculator magic. 4x squared minus 12x plus 9. So that's what we are subtracting. But be careful here. Please make sure whatever you do that you put parentheses when you subtract. The most common mistake in the world with this is kids just subtract these two. They're just like, oh, 5x squared minus 4x squared is x squared. And then they write the minus 12x plus 9. And of course, this one is waiting here. Okay, this one, please don't pick this. All right, bear trap if you do. All right, so that's not what you want. You actually have to distribute. So you distribute the negative like this, and you get 5x squared minus 4x squared, but then you get minus 12x is plus 12x. And then you get minus positive 9 makes minus 9. So then you get x squared when you combine these two, plus 12x minus 9. So choice 3. All right. Or when in doubt, pick C. That works here too. Great. So that is question 10. All right. Oh, and for people here, if this is helping, if you haven't subscribed, please consider subscribing. Help me grow the channel. I'm trying to get to 50,000 subscribers. That would be so awesome if I get there. Why is there always traps? Because, I don't know, you got to ask Albany, upstate. It's their way of... The Regents is like, I'm not like... There's some things I would change if I could, and I guess that would be one of them, like them like deliberately just trying to trick you, but that's one of those, like, it's good that you know not to do that traps. They also have to distinguish between, you know, people who know like everything, and that's how they like distinguish like a 90 from like a 99, let's say. NumWorks, I do. I actually was gifted this NumWorks calculator. Yeah, one student gave me like a ton of stickers too, so I did put stickers on it. But I don't know how to use it though that well. I haven't like really got into it. But if NumWorks is awesome, then great. Like, be good at NumWorks. But Desmos right now might be king. I don't know which one is best, but Desmos is like very overpowering. All right, so Joe has a rectangular patio that measures 10 by 12. He wants to increase the area by 50% and plans to increase each dimension by equal lengths x. Which equation could be used to determine x? So this one, I usually draw these out. So this is like 10 by 12. And the area, so just remember back to like, you know, third grade, even 10 times 12 is 120. So the area is 120 square feet. So 10 feet, 12 feet, the area is the space on the inside, would be 120 square feet. And his goal is to increase the area by 50%. So 50% is the same thing as 50 over 100, which is a half. So what you're really doing is like, if you take half of 120, like the math that I do in my head, so half of 120 is 60. So this has to go up by 60. So the new area has to be 180. And they told us here, he wants to increase each dimension by equal length x. So that means 10 has to go up x, and then the 12 has to go up x. So then how do we solve? We would multiply area is length times width. And in this case, it would have to be equal to 180. Okay, so 10 plus x times 12 plus x equals 180. So choice 2. All right, 11 is choice 2. Whoop, I was just joking. This one. Cool. All right, next example. So let's see. We have when factored completely. So this is also like all calculator. Type in the question and all the answer choices. But let's say I actually want to do this myself. I would factor out an x, and then that would make x squared minus 13x minus 30. And then this, I would factor this quadratic part into x, and then I'd have a minus and a plus because we're multiplying to a negative. And the numbers here would be 15 and 2. Reason being, negative 15 plus 2 is negative 13. And negative 15 times 2 would make negative 30. Okay, so we're looking for x times x minus 15 times x plus 2. It looks like choice 3. So 12 is choice 3. Okay. If you're like, whoa, that's too much algebra, then you're going to go like this. So x to the third minus 13x squared minus 30x. And then I type in all the answer choices. And by the time I get to choice 3, I should have a match. So let's see. So we do this. See, they overlap. You could also press second graph and look at the table and say, hey, all the y values are the same for each x. So choice 3 is definitely good. All right. So let's see. Question 13. What do we got? During which time interval did the cost increase at the greatest average rate? So this is average rate of change. I'll abbreviate average rate of change like this, which is really just, I just think of this and I'm just thinking like, oh, slope. So I just think like y2 minus y1 over x2 minus x1. And you find the slope between all of these, and it's during which time interval did the cost increase at the greatest average rate? So that we want to see like change in the cost like per year. So let's see, like over this space here to here. So it was 1 cent and then it became 6 cents. So that's 6 minus 1 divided by, I'm just going to use the calculator for this. I'm just going to do that as we look. So let's see. So back to the main screen. Now, if you don't know this trick, alpha y equals enter makes a fraction. If you have the newer TI-84 plus CE, you could just press alpha x to make a fraction. And then I do 6 minus 1, and I'm dividing by 1971 minus 1898. Okay, so that would be for choice 1. And see, oh, hang on, do mode and then go to decimal because I don't feel like thinking in fractions. So I'll do this again. So we get this amount here. And then for the next one, I would do fraction and then 14 minus 6 divided by 1985 minus 1971. So that's for choice 2. So let's see. 1985 minus 1971. And we get this. So far, this is already a bigger increase than this. Okay, so now we move on 1985 to 2006. So that's 24 minus 14. I'll pretend I don't know. That's 10. And then 2006 minus 1985. So less. All right, now moment of truth. The last one. We're going from 2006 to 2012. And it's an increase of 11 cents. Okay, but 35 minus 24 over 2012 minus 2006. And this is the only one that's more than 1. So choice 4 is already going to be our answer. All right, so just to break that down, if you're like, whoa, what just happened? So we're just finding the slope between like all the pairs of points in this. And the one that was the greatest was the slope between these two. Okay, so that's why choice 4 is our answer. All right, so just find slope 4 times and say which one's the biggest. All right, so next question. This got chopped, so let me move that over. When solving the equation here by completing the square, which equation is a step in the process? So for this, completing the square, I like to move this. So like move this to the other side. So let me just do that higher up. So I start by going plus 7. I'll leave a space is equal to 7. And now I complete the square. So I have the b value is -8. I divide by 2 and I square it. Okay. And then that makes -4 squared is 16. So I go plus 16 on both sides. And then from here, this left side factors nicely. X minus 4 times x minus 4 equals, these make 23. All right, I know these are good because -4 plus -4 is -8. And -4 times -4 is positive 16. And this makes x minus 4 squared equals 23. So choice 2. All right. Cool. So 15, a construction company uses the function f of p, where p is the number of people working on a project, to model the amount of money it spends to complete a project. A reasonable domain for this function would be, okay, so for this is like, remember, domain is possible x values. Okay, so here, if the domain, in this case, our domain is the variable p, and this is number of people. Okay, so what would make sense here? Positive integers is the only one that makes sense. Reason being, you would say like, oh, I have 2 people, 3 people, 5 people. Positive real numbers, like try saying that in a sentence. Like, oh, I have pi people. You know, like just think about that. Like square root of 2 people. Pi people. Like that doesn't make any sense at all. Please don't ever say that. So this is gone. Negative integers. No, you wouldn't say, oh, I have -10 people. Like, no, don't say that. Positive and negative real numbers. So you wouldn't say, oh, I have negative square root 2 people. Like that doesn't make sense. The only one that makes sense here, the only appropriate domain is positive whole numbers, if you're talking about people. All right. Good. This one is a little tricky, but I think the idea is, how do we rule things out? So like these 2 answer choices here are linear. The regions don't come out, like the new ones, until like a few days, like well after the regions. Yeah, they take some time to get those out there. So just pointing that out. All right. So here, linear, I'm looking for a constant rate of change. Okay, but the problem is, like, let's say I don't like fractions. From 1 to 3 is like, oh, plus 3. And then this is plus 6. And this is plus 18. But notice the amount that we're going up by each time is, oh, that was a joke, by the way, plus 3. I was just testing everyone. That was really plus 2. Okay, yeah, 1 plus 2 is 3. 3 plus 6 is 9. 9 plus 18 is 27. So you see, like, this is like not, non-constant rate of change. Okay, each time, like, the amount it goes up is multiplying by 3. So you might say, ooh, like, but not x to the third. It's going to be 3 to the x power. Right? We could even test it. We could just plug in and see, like, f of 1 is equal to 3 to the first power is 3. F of 2 is equal to 3 to the second power, and 3 to the second power is 9. F of 3 equals 3 to the third power, and this is equal to 27. So that's why this one. All right. you could say like, oh, but this works for like 1 works if I plug in 1. Yeah, but if you plug in 0 here, like 3 times 0 is 0, and you don't have 0, 0, you have 0, 1. So you could just like brute force plug these all in. But I look for like the constant rate of change versus non-constant. Can I do living environment? No, I would feel like wrong trying to teach you something that I don't. I did take, I was telling my students today, last summer I took biology, a CLEP biology. It's like a college board thing because I needed to get like my 30 extra credits to get my max pay rate as a teacher. So I studied for a bio test, like much respect to people. But yeah, with bio, it's just, you have to just, yeah, I don't know. I'd have to like, you know what I would do? Like when you get old or even when you're young, don't like try to pretend you're like an expert at everything, you know, like math, I'm comfortable explaining, but bio, I would probably like pass it on to a bio teacher. But the advice I got, because when I had to study for this bio test, I went to like the bio person in my school, and I was like, hey, I got to take this like heavy duty bio test. And he was just like, yeah, just like, you know, crack one of those textbooks open and just like power through it, like reading the definitions and not just knowing definitions, but like knowing how all the different systems interact and whatnot, like the stages of like, you know, mitosis or whatever, stuff like that. So like I found like drawing the diagrams out helps because then like it burns into your memory more. Like if you're drawing it instead of just like passively listening to someone else explain it. So like sometimes like note taking and drawing it helps for retention. But otherwise, just good luck on your bio test. I can't really give that much good advice because I took bio over 20 years ago at this point. So yeah, great. All right, moving on. Given the functions this and this, which value of x makes them equal? So this one you could just plug in until you get there, but like you do have a calculator, so why don't you just, you know, definitely do that. So this is 1/2. I could say 0.5x. And then plus 3. And then the absolute value, you press math, go to the right to number, and ABS doesn't stand for abs. It stands for absolute value. And you put the x. Then we graph it. And we have 2 answers. We have one at negative, let's see, which values make these? Oh, we have one at -2 and 6. See, at -2, the y values match. And at 6, they match. You could press second trace 5 to find the intersection. And then just go up to the intersection. You press enter 3 times. So when x is -2, y is 2. Okay, so 17 should be choice 1. All right. Cool. 17 is choice 1. Yeah, I do teach. You know, I did for 2 years teach physics, but I was teaching it out of license because there was a shortage of physics teachers. But I was like, sure, I'll do it. It was like, you know, something fun. All right. Oh, this craziness. Okay. So here, how do we... All right. So which recursively... So it's like when I hear that, it's like based on the previous. Okay, I think of like recurring nightmares, like Freddy Krueger would be a recurring nightmare, and it's like always like building off the previous. It's like, oh, there he is again. It's like the same monster sort of thing. So sorry if that's like too scary of a metaphor for this, but that's how I like to think of these. So my first thought process when I'm like going through this is I look for what is the pattern. Which the pattern might be obvious, but it's okay if it's not. Like +4, then +8, then +16. So you see like the amount it's increasing by each time is doubling. Like the next time it would go up by 32 and then 64. So we just kind of have to see here like which one is making the most sense. Some people might say, all right, like that's how much it's increasing. Or some people might say, all right, we're going like times 2 and then +1. And that seems to work too. Like if we go that route, see like 3 times 2 + 1 would give us 6 + 1 is 7. Oh, we said it. All right. So 6, 7 there. But then if I do it again, times 2 plus 1, 7 times 2 plus 1 is 14 plus 1, which is 15. 15 times 2 plus 1 is 31. So that seems to be it. But you see what's going on is we multiply the previous. So now I put it in words. So multiply the previous term by 2. By 2. Then add 1. See that? So I multiply the previous term by 2, then add 1. To get the next thing, I got to multiply the previous thing by 2 and then add 1. So I look here, and it looks like choice 3 right away. See, like 2 times the previous term plus 1. If you're like, whoa, what on earth is happening? Watch what happens if I do this. If I plug in, like over here, so I plug in 2, like let's say I want to find what's going on at 2. So how do I get that? See how it's n plus 1? I say, all right, if n equals 1, I get f of 1 plus 1 is equal to 2 times f of 1 plus 1. And now this tells me f of 2 equals 2 times f of 1. And f of 1, they told us, is 3. Plus 1, and that gives us 7, which is the second term. And if I plug in, now I'll do this over here. So pattern, looking for patterns. So if I plug in n equals 2 into the formula, see I get f of n is 2, and then I write my plus 1 equals 2 times f of 2 plus 1. So now I get f of 3 equals 2 times f of 2 is 7 plus 1, and this gives us 15. So definitely this one. All right, great. Yeah, elimination definitely helps at the bio comments here. But good luck on bio. That might be harder than this. Is this on the reference sheet? That's a good question. What is on the reference sheet? The reference sheet is like mostly useless, I think. Let me see. Let me see. The reference sheet. Wait, I just. Oh, they give you this. So I'll just screenshot it. All right, quadratic equation, quadratic formula, axis of symmetry, slope, equations of a line, exponential, arithmetic, geometric sequence, interquartile range, outliers, all that fun. Okay, great. All right, the range of this function. This one might be like a little outdated, not going to lie, but I mean, it's still good to see. But an exponential function like this, y equals 5 to the x, we could type in the calculator. It's going to look something like this. Okay, and it passes through the point 0, 1. The range is the set of all possible y values. But if you see here, the y values are all positive. Okay, y is strictly greater than 0. Okay, it is not possible for this to equal 0. All right, 0 equals 5 to the x has no solutions. Okay, this will never be true. Okay, 5 to no power. People say, wait about it. What about x equals 0? But no, 5 to the 0 is equal to 1. That's why 0, 1 is here. Okay, we start getting closer to 0 as we move left, but strictly positive. All right, exponential functions are always positive when you have a positive base like this. Okay, but that, like I said, is a little like outdated. I don't remember seeing that on recent ones. Transformation of functions, that is in fact very real. So if we have f of x, which graph shows f of x plus 1 minus 2? So this part here is like, don't say to the right one. The right one is a trap. It sends us to the left one. And then minus 2 outside sends us down 2. So the constant outside the inner part of the function sends you in the same direction. This one is opposite. So just be careful of that. So what I'm thinking is, all right, left 1, down 2. So this one I would go left 1, down 2. This one I go left 1, down 2. And then this one I would go left 1, down 2. And then this one over here, left 1, down 2. And now I connect. Oops, can't draw. Still can't draw. All right, that's better. And it should look something like this. All right, not my best artwork, but it should match up here with choice 1. Okay, choice 1 is our best possible answer. See these 2 points in green and red here at -2, 0 and -3, -1. So that's what's going on over here. Like if we just match the points. See like green, red, purple's at 1, 1. And then this one here is over here matching. Okay, so this one. The other answer choices are just off. So no to the rest. Okay, if you forget that rule, you're like, oh no, I forgot the rules. What do I do? Calculator will save you. But pick something easy to reteach yourself. You know, like don't pick something complicated. Pick x squared. X squared is great. All right, there's x squared. If I did x in parentheses plus 1 and then squared, and then -2 outside, see how I go to the left 1 and then down 2. So left 1, down 2. Like you could use the calculator to reteach you rules. That is a great skill to have. Okay, the ability to reteach yourself on the spot. So 20 should be choice 1. All right, let's check the chat here, how everyone's doing. All right, let's see. Just catching up. Oh, that's right. We did have 67 people watching. It's wonderful. All right. Oh, this one's annoying. This is like, all right, when they do this, they're trying to like remove the calculator from the question. Like that's them being funny. So, okay, they got us. So let's think about, like what I do is I look for connections. So 4x plus 2y is 22. So this is the same. But this, see how this one changes. So here to here, what was the change? Well, it's like they took this and multiplied by -1 to get 2x minus 2y equals positive 8. Why they do that? Because then these eliminate. Elimination. So which one could not be used? So this works. So it's out. All right, so this one's out. Now, let's see. Choice 2, 4x plus 2y equals 22 is the match. But now, what do they multiply by here? It looks like for choice 2, they took -2x plus 2y equals -8. And they multiplied everything by positive 2. And you get -4x plus 4y equals -16. And then here, the x's would eliminate. Okay, so 2 is a valid next step, which means it's not our answer. We want the one that doesn't work. So that's out. All right, now this one looks like they multiplied both. So from here to here, see how they went just times 3? Okay, so multiply by 3. And then from here to here, it looks like they did times -3. So let me just show that over here. -2x plus 2y equals -8. If we multiply everything by -3, that makes positive 6x, and then minus 6 times y equals positive 24. And then y's would eliminate. So this works. So just by process of elimination, it has to be this one. But let's see why this one's no good. So for this one, they took the first equation here, 4x plus 2y equals 22. And they went times 2. So they got 8x plus 4y equals 44. All right, so that one worked. However, from here to here, it looks like they tried doing times 4, but let's see where things went wrong. Oh, the right side is where things went wrong. So if I take this bottom equation and I go times 4, I get minus 8x plus 8y. But the right side, 4 times negative 8 is negative 32, not negative 8. So that's why this one's no good. All right. So let's see. Which function has a minimum that is less than the one shown in the graph? So calculator all the way. Calculator. So minimum value. So the minimum is over here. That's the minimum means like the low point. Okay, so the minimum is here. That's down 1, 2, 3, 4, 5, 6, 7. All right. So here over 1, 2, 3. All right. So 3, negative 7. So this, the minimum value. I'll just write so minimum value is equal to negative 7. So we have to try to go lower than negative 7. All right. So let's see. Now answer choices. So y equals x squared minus this. Okay. And then choice 2, math, go to the right. ABS. X plus 3. Hit the right arrow so you get out of that, because how many students just keep writing and they stay in there and then you lose that time. You never get those seconds back in life. I've lost many seconds in there. Okay. And then math, go to the right. Absolute value. X minus 8 and then plus 2. All right. Now, we have to go lower than negative 7. Remember, that's the low to beat. So I can even do this. I'll graph y equals negative 7 and see which one goes lower. So the quadratic here in black wins. So it looks like choice 3 is the lowest. Okay, choice 3. So, and if we even look here at choice 3, see how the low point goes to negative 11, which is less than negative 7. See, there it is. So negative 11 goes lower. All right. So choice 3. So just graph all of them and see which one goes under. Cool. All right. Question 23. Oh, when you tried min on the calculator? All right, hang on. Let me try. So if I actually trace the minimum, second trace minimum is number 3. Like let's say I do it for this one. I press enter. Like see how I'm like before the minimum, then I go to the right. And if the calculator freaks out, I'll show you a workaround. Oh, you have see y equals negative 11. So enter to the left, enter to the right, and then enter a third time. All right. So Grisham is considering the 3 situations below. For the first 28 days, the sunflower grows at a rate of 3.5 centimeters per day. The value of a car depreciates at a rate of 15% per year after it's purchased. And the amount of bacteria in a culture triples every 2 days during an experiment. Which of the statements describes a situation with an equal difference over an equal interval? All right, equal difference over an equal interval is linear. That means like you're rising and running by the same amount each time. That is a constant rate of change. Okay, so think about that. Constant rate of change. So if this one will, it looks like this one works. 3.5 centimeters per day this is a constant rate of change. Okay, this could be like, I don't know, let's say the sunflower is like X and Y. And let's say it starts out like 10 centimeters tall. Then like a day later, it would be 13.5 centimeters tall. And then another day later, it would be 17 centimeters. So it's going up by the same amount. It's increasing by the same amount over equal intervals, like per day. So 1 is definitely true, which means these are out. Now, depreciation is exponential in this case. That's this formula. When you have a variable that is an exponent, this is exponential. Okay, and exponential growth or decay. So 2 is not it. So now let's see 3. If the bacteria triples every 2 days, well, this is also exponential. So let's say there's like, I don't know, like 100 bacteria on, wait, I'm sorry, that's the Y value. So 100 bacteria on like day 0. Well, 2 days later, times 3 would be 300. And then 2 days later would be times 3 would be 900. And then 2 days later, it would be 2,700. So you see like equal X's, but these are not going up by the same. It's going up 200, 600, 1,800. So just 1. Okay, 23 is 1 only. Yeah. All right. Oh, completing the square, just like rewind back to... I might do a question like that later, though. Let me see. Is there a question where they're like, hey, complete the square? But I did a completing the square question, like, I'll tell you when. It's a long time ago. Question 14. So rewind back to question 14. I show how to complete the square. When they say factor completely, that just means like keep factoring until you can't factor anymore. All right, like they almost always start you with like an x to the third expression. But even something like this, like if I had x to the third minus 16x, like first I do this. This would be me factoring, but like not completely. Like this is just, oh, I factored. I wrote something as the product of two things, but completely, then I would say, all right, is x times x plus 4 times x minus 4. So that's what we mean. All right, question 24, last multiple choice. Oh, this is old. Not on the Regents. Yeah, this is not on the Regents. What it used to like represent is like when you have like a scatter plot like this, and you know you make a line of best fit, like something like that. They used to call this residual values, and it would be like them measuring the distance between the points and the line of best fit. So here, like a good line of best fit is going to have points above and below. So they treat the distances here as like, oh, positive, negative, positive, negative. So choice 3 in this case would be it, because like it's like, oh, it's kind of like they take this whole thing here. Let me see if I could just group this. We do this. So group and then rotate. It's like they just treat it. This is like a weird topic, but wait, why is this not spinning? Oh, here we go. And it's like, oh, which one could be it? And it's like, oh, that's why this one, because it just like it's like they take the line of best fit and throw it on the x-axis. So it's a weird question, old, outdated, not on the Regents. All right. This one, though, is, so now part 2s. Let me get a sip of water. Yeah, I mean, so I appreciate the comment. Lost my account, or whatever it stands for, but I started doing these live streams like a few years ago, and like when I started putting the Regents videos out and I saw how much people were watching them, especially around Regents time, and you know, just the positive feedback that I got, I do enjoy making these. And my favorite comments to read are like kids were like, oh, you know, I really struggled in math, and like my average went up big time, or I thought I was going to fail the Regents, but I studied a lot and I used your videos to help, and then I wound up passing. Like, I think more kids could get through this test. And yeah, I mean, tutoring, like, people have to make money, but like to have to pay like, you know, $60 to $100 an hour for a tutor, when like you could, like, if you just sit down and concentrate, learn a lot of the stuff yourself. You know, like tutoring is great, but tutoring only works, because I've private tutored before too, if like you're doing the work outside of tutoring. And you all here right now, like staying on for this review, are willing to do the work. So like that's really awesome that, you know, you're choosing to be here. But yeah, big long-term goals for the channel. I'm making a playlist and I'm calling it, kindergarten to calculus. And I want to make like full year math reviews for kindergarten all the way up to calculus level. So like if someone's like, oh wow, 5th grade was like my worst year ever, like they could just download the PDF for free, print it, work on it, and then like watch a video walking them through whatever stuff they don't know. So yeah. But yeah, rewind. I'm not gonna like have me repeat it like me at whatever time it is. It's like 6:04 or 6:05 right now. But rewind for sure. Or watch the replay when you're done. All right. So question 25. So determine if this function is linear or exponential. So this is going down by 2.5. Down by 2.5. Down by 2.5. And then same thing here, down by 2.5. This is increasing by 2, the x's. See, I'm going up 2 in the x direction. So let me just make that look. That looks pretty terrible. I don't want that to. So plus 2. And then from here to here is plus 2, plus 2, plus 2. So you see where my head goes is like, oh, constant rate of change. So linear. So I would say t of x is linear because it has a constant rate of change. The Regents loves buzzwords. And when you say linear, like they really want to hear constant rate of change. Okay, because it has a constant rate of change. Okay. Don't say like when I imagine it, I see a line. Like that would be. How should you know how much it's going down by? So for that, you could just subtract. So second mode, back to the main screen, and I just subtract like 7.5 minus 10. C is 2.5. If I do 5 minus 7.5, see, I get the same difference each time. Okay. You could also do this because you should know this skill too. Stats, edit. I could write all these values in like -3, -1, 1, 3, and then 5, and then type this in and say 10, 7.5, 5, 2.5, and 0. Okay, I'm going to hit stats and go, whoops, I'm sorry, I'm just mode, and I'm going to turn stat diagnostic on so I can find the correlation coefficient. So then calculate linear regression, number 4. See, r equals -1, which means it's like a perfect linear fit. So this would be the line, y equals -1.25x plus 6.25. Okay, so y equals -1.25x plus 6.25. And now I'll clear out all the other stuff. Okay, so here, that's another way here. See, -3, 10, -1, 7.5, 1, 5. Like you could actually get the equation that way too. All right. So let's see. All right, so moving on to the next question. Sorry, I was just thinking out loud. Marcel claims that this is a function. Is he correct? Justify your answer. No, Marcel is wrong. Sorry, Marcel. All right, why is Marcel wrong? So here, this is not a function because it fails the vertical line test. See, this vertical line gets the function twice. Some people learn like the repeating x value idea, like if your teacher taught it that way, which is also good. So you see how like the x value here, 2, goes to -1 and 3. And like that's bad. Like repeating x values going to 2 different y values is no good. But I would say state whether Marcel is correct. I would say Marcel is incorrect. And I would say because, I know for justify, you just show the math, but I'll just write a sentence. Marcel is incorrect because the graph fails the vertical line test. All right, if you spell wrong, you still get the credit. This is not the English Regents. Fails the vertical line test. And that's it, 2 points. Not a function of x. Okay, so you see it hits the graph twice. If, however, let's say instead this were the graph. If there was an open circle here, like if this was open, then Marcel would be correct to say this is a function. But it's not open. They're both closed. So that vertical line here would make it fail. All right. So that's that. Question 27, solving a quadratic. So this one, you know, they didn't tell us not to use the calculator. Although solve the equation for y. Yeah, solve an equation kind of means, hey, do algebra. All right, so you ready? Y minus 3 times y minus 3 equals 4y. Oh, wait, there's another way to do this, but yeah, there's, you know what, whatever. I'll just do this. I'm not going to get, don't get fancy at the Regents. Just like stick to the boring, safe ways. But I was like, oh, wait, I just saw something. Like, what if you did this? And then you divide both sides by y equals 3. That would be cool. And then y is equal to 7. Is let's see. Oh, yeah, one of the answers is 7. Look at that. So 7 and 3. That's pretty cool. But don't do that. I'm going to show you how to factor. All right, that's like for fun. But yeah, ignore me on that one. Okay, so here, so this 4y minus 12, and then just expand. Y squared minus 3y minus 3y, negative 3 times negative 3 is positive 9, equals 4y minus 12. Okay? And for this, now you can combine like terms and say y squared minus 6y plus 9 equals 4y minus 12. And now move everything to the left. For quadratics, when you're solving them algebraically, you want to make everything go to one side and you want 0 on the other side. So y squared minus 10y plus 21 is equal to 0. And then you're looking for two numbers that have a sum of negative 10, and they also have to have a product of 21. That would be negative 3, negative 7. So y minus 3 times y minus 7 would do it. Because, once again, the math I do in my head, negative 3 plus negative 7 equals negative 10, which is the middle. And the product of those two numbers is positive 21. Okay? And then you set each factor equal to 0. And you get y equals 3 is one answer, and y equals 7 is the second answer. All right. If you write the correct equations down and stuff like that, you do get partial credit. Like, just know, like, the teacher's grading, I would say for the most part, most teachers are like nice and they're going to want to see you like do well and they'll give you credit. All right. Like, I'm not looking for reasons to take off points. I'm like, I want to find points for you. So like let's say you get to this step and then you mess everything else up. Like, all right, 1 out of 2 for like doing the algebra correctly and getting to this. So, you know, just do what you can. This is a lot of work though for 2 points. Okay. So this one here, this one was a little tricky. The graph below shows the variation in the average temperature of Earth's surface from 1950 to 2000, according to one source. I like that. According to one source. Like, who's the source? All right. Determine which years... during which years did the temperature variation change the most per unit of time? Explain how you determine your answer. So for this one, I'm just looking at the slope. Okay, so temperature variation, just know the trap here. This could be positive or negative. So a steep rise or a steep fall? All right, so let's see. So this, not this one, because this is 0. I'm going to introduce you to slope guy. So positive slope, lines go up. Negative slope, lines go down. Vertical line, slope is undefined. And a horizontal line has a 0 slope. And it makes slope guy. If slope guy gives one person a nightmare today, then slope guy did his job. No, this will just help you get better at slope. So I see this, I'm like, oh, 0 slope. So probably not from 1950 to 1955. So here, this is like, see, it's like up 1 over 1. And then this one is down 3 over 1. All right, so this one so far in pink, this one is steep. All right, and then this one is like same as the red over here. It's like up 1 over 1. So like that's not exciting. And then this one's 0 again. And then from like here to the end, it's up 2 over 1. Okay, so this is like steep, but it's not as steep as down 3 over 1. Okay, so it's like this one is, whoops, let me just fix that. Sorry, technical difficulties here. All right, here we go. Yeah, because it's like tricky sometimes organizing the calculator plus everything I got going here. All right, so it looks like this is the one. All right, and how do we know? Because the slope is the steepest there. Okay, so we're looking for when is the slope the steepest. So during which years? Explain how you determine your answer. From 1960 to 1965. And now explain. So I just have to write a simple sentence. I could just say the slope is, make that neater, the steepest. That means it rises or falls at the fastest rate. Okay, so it is the steepest there. All right, if you want like, hey, I want precision, then you could use the slope formula. Like if you want to say a little more, you could say, all right, so from here to here, this is like 1965, comma, see, this is already like awful, negative 0.15. Like if they're counting by 0.1, this is 0.15, but negative. And then this one over here, it would be 1960, comma, 0. And if I find the slope, so I get negative 0.15 minus 0 over 1965 minus 1960. This would be this number, but then over 5, which would make negative 0.03, and it's degrees Celsius per year. And then I would do that for all of them, but this one would just be, it looks like point, like this one here, the slope is 0.02 per year. Right? Yeah, because these are jumping by 5. So if I look, it's like, all right, this would be up 0.1, but then over 5 would make 0.02. So see, like this slope, even though it's negative, it's like absolute value is greater than this. But that's like way too much work for 2 points. So like just say, hey, the slope is steepest there. Like this is plenty. This is, very extra. Okay. Okay, so here we are. Oh, wow, we almost got 1,000 people to come to this live stream. Thank you once again for the support. And if this is helping and you haven't subscribed, please consider subscribing. I did have a goal like, 50,000, but it's all right. YouTube is more of a marathon than a sprint. If I get to 50 by the end of the year, that'd be so cool. But if not, like that's cool too. I'm happy either way, just to be here helping people and, appreciating that the chat, everyone so far has been very cool. So, thank you for being here and good luck to everybody tomorrow. I hope everybody here, does well, passes or gets the high grade they want to get. Wishing you all the best. All right, let's see. Just thinking out loud. Okay, so moving on to the next question. Oh, wow, they really like these linear whatever questions. So this was that year, I guess. So for these questions, what does it all mean? Applied. Y equals mx plus b. This tells you the rate. like per unit of time. So it's like in a graph, it's like just slope and y-intercept. But in word problems, it's the rate and it's like the initial amounts. Okay, so I just think about that before I even get into the question. So, ready? The cost of belonging to a gym. So the cost of belonging to a gym is C of M. C of M is the total cost for M months of membership. And we want to know what is the meaning of the slope is just the 50 and the y-intercept is this. Okay, so think about it. The slope is the rate and the y-intercept is the initial amount. And just be mindful here that M is in months. So think about this very carefully. The cost of belonging to a gym where they tell you M is in place of X here. That's annoying they used M when M usually means slope. Like that was their way of being cruel. But whatever. So this is the monthly fee. Okay, so the slope, I'll just say here the slope, which I'll just say is, 50, represents the monthly fee. And the y-intercept, which was 79.50, is the cost, what is this, a gym? So that's like the cost of joining the gym, is the cost of joining the gym. Okay, which, me saying the cost of joining the gym, it's like you pay it once. Okay, because you join the gym once, and then you pay your monthly fee. Cool. All right. So now, question 30. Conditional probability, maybe? Something like that. Not conditional, but whatever. We'll just read this. Okay, a little water break. He has a lot of talking for this. All right. So here, a stats class surveyed some students during one lunch period to obtain opinions about television programming preferences. The results of the survey are summarized in the table below. Based on the sample, predict how many of the school's 351 males would prefer comedy. Justify your answer. So justify just means like show the math based on what they give you. So here, if we look, predict how many of the school's 351 males. So that tells us like just consider like the males of the school. Okay, so here, if we look at the total, that would be 105. If I did 70 males prefer comedy, 35 males prefer drama, out of 105 like male students total. So here, let's think about the probability. Well, how many of the school's 351 males would prefer comedy? So if we look at just comedy, 70 out of the 105 males prefer comedy. So we would just take this fraction and multiply by the total number of males, which is 351, and see what we get. So let's see, how does this work? 70, I'll just do it like this, alpha x. And then times 351. 234. Okay, that works out to 234 exactly. There it is. Okay, so this is like how many males prefer comedy out of the 105 total males in this survey, but they're like scaling it up to model for the whole school. Okay, it's not every, what this means is like not every kid took the survey. So they're just going by the sample. All right, this question here was difficult. All right, so watch out, like serious bear trap. All right, I actually made this one into a YouTube short and a TikTok. My TikTok channel is like the same title as this one. I just started recently. My students were telling me to do that because they said more high school kids are on there. So I'm like, all right, might as well join the fun. So here I do b times x minus 3 times b. And we're solving for x. So I have to solve for x. Greater than or equal to, and then let's see, I have ax plus 7b, so I'm solving for x. So if you had like, just imagine for a moment, like, I don't know, 3x plus 1 equals 7x minus 4. You would move the x's to one side and you would move the constants to the other. So like that's kind of what I'm going to do here. I'm going to say minus ax on both sides and then plus 3b on both sides. All right. So here, these cancel, and we have bx minus ax is greater than or equal to 10b. But now my goal is still to solve for x, so I'm going to factor x times b minus a. I can factor out the x, and then I have 10b on this side. But now this is where the bear trap of the century. You ready? A lot of students here just divided by b minus a. And they're like, great, I'm done. And they said x is greater than or equal to this. And then cue the bear sound. All right, they told you, sneaky detail, that a is greater than b. So for this, and make this neat, if a is greater than b, that has the same meaning as me saying b is less than a. And if b is less than a, if I subtract a on both sides, I get b minus a is less than 0. Which means b minus a, so this tells you b minus a is negative. And if you divide by a negative, so divide by a negative, this means the inequality flips. Okay, it's going to flip. And we're going to say x is less than or equal to 10b over b minus a. All right, evil stuff. Very evil stuff. So that's just something I want to point out. Great. All right. Okay, let's see. How are we doing? Oh, wow, we're starting to get more people to the stream. So thank you to anyone just joining. And if you've been here a while and you haven't subscribed, please consider subscribing if this is helping. All right, it does more subscribers, it makes the YouTube algorithm happy, and then they start sending my videos to like more people. So I just want to keep growing the channel. I really, I know you shouldn't like chase a certain number, but the one I really want the silver play button one day. That would be so cool, like hanging behind me next to the bear and my jiu-jitsu belts. But yeah, that would be cool. All right. So this one, Jacob and Jessica are studying the spread of dandelions. Of course they are, because it's the Regents. All right. Jacob discovers that the growth over t weeks can be defined by this function f of t. And Jessica finds that the growth over t weeks is g of t equals this. Calculate the number of dandelions that Jacob and Jessica will each have after 5 weeks. So this means plug in 5. So you ready? F of 5. Let me fix that, make it look a little nicer. F of 5 equals. So you see I'm plugging in for the variable t is here and there. And then over here it's here and here. So I just plug in. And I get 8 times 2 to the 5th power. All right. Now, if multiplication isn't your jam, then just use a calculator. But we're really just doing 32 times 8. Here, we'll make our elementary school teachers proud. Don't actually, you know what, maybe this is bad. Don't do this at the Regents. Just use the calculator, because if you do this and you mess up, it's like real tragic. But let's hope it's 256. All right, 8 times 2 to the 5th power. It is, yay. If you don't even trust yourself on that one, you could just type in 8 in parentheses, and then 2 to the power is this button above division. You put your variable, and then 2 to the power x plus 3. And if we go to 5 weeks, second graph, and go to 5, see they actually both give you 256. So we'll get 256 also for Jessica's function. Okay, so the next one, though, be careful. Call it g of 5. Is equal to 2 to the 5 plus 3, which is 2 to the 8th power. I don't even have to simplify that like that. I could just say 256 because the calculator is doing all the work. Okay, so that gets us credit for the first part. Based on the growth from both functions, explain the relationship between f and g. Well, for this one, little side quest. So on the side quest here, remember this rule. A to the b times a to the c is a to the b plus c. And a to the b to the c is a to the b times c. So something like, actually I don't even need that one here. F of t, instead of calling it 8 times 2 to the t, I'm just thinking here how 8 is equal to 2 to the third power. So I could say 8 times 2t is the same thing as 2 to the third power times 2 to the t. And then I use this addition property. This is 2 to the 3 plus t, or I could just say t plus 3. Okay, which then tells us that f of t is equal to g of t. See how like f of t could be rearranged algebraically and it works out to g of t. But they're saying here, like, explain the relationship based on the growth from both functions. Okay, so based on the growth. So if we, work through that one more carefully here, they both have the same growth rate. Okay, see how they're both doubling here? A base of 2 means that the amount is doubling. And you can even look, like, let's pull up the calculator. See how, like, at the beginning it's 8 and then each week doubles. I'm sorry, is it weeks? No. It's t is, oh yeah, weeks. Every week that goes by, the dandelions double. So, because they're saying explain it based on the growth rate. If I just say, hey, algebra shows they're equal, that's not basing it on the growth rate. You have to answer the question they're asking, not the one you want to answer. Like, you have to answer what's in front of you. So just remember that. So here, I would just say the f of t equals g of t because they have the same. And for this, I would say exponential growth rate because doubling each week is exponential because they have the same exponential growth rate. I would just say, like double each week. You can even say like they double each week. Each week. So here, let's just summarize this. F of t equals g of t because they have the same exponential growth rate. They double each week. I want to point out too, also I showed above using exponent properties that f of t equals g of t. So that like kind of touches like the growth rate aspect, and hey, I did the algebra too to show they're equal. Like, if you're unsure, just write a little bit more and just say all the things you did, and they'll be like, all right, we get your idea. All right. Oh, part 3. Now everything's worth more. This is a classic question, the launching a projectile question. So that's something that, you could expect. So let's see. Part 3. So moving on here. So let's see. We have... all right, h of t is, let me zoom in. And let me just double check. This Regents is 37. All right, 37 questions long. Okay, so we're getting there. All right. So for this one, we have h of t is the height of an object above the ground after t seconds. Determine the number of seconds it takes to reach maximum height. Justify your answer. And then we have to state the time interval at which the height decreases. Okay, so maximum height, I just want to point out, like what I'm thinking of is like this is going to look something like this. Okay, and it stops here because like the object is like not going through the earth and just like going to the core of the earth. It's going to stop when it hits the ground. Okay, but the maximum here happens at the axis of symmetry. And that's one of those formulas they give you on the reference page. Okay, so if you look, the equation of the axis of symmetry, they tell you like x equals negative b over 2a. So I could do that because they said determine. They didn't say algebraically, but let's say I want to use that. I would say, all right, t equals, and remember, it's always like y equals ax squared plus bx plus c. So negative b would be negative 64 over 2 times a would be negative 16. And then negative 64 divided by negative 32 is positive 2. So determine the number of seconds it takes to reach maximum height. I would just say 2 seconds. All right, it's going to take 2 seconds here. And that would count as justification because I'm using the formula. So I would say t equals 2, so like 2 seconds. Now let's say you're like, that doesn't make sense. Like somebody save me. You could just graph this. Also, but now you got to be a little more savvy with the calculator because you go to graph this, and I see this happen with students all the time. You graph, and then plus 80. And you're like, oh no, I can't really see how high up this is going. When is it happening? And that's because I press second graph and go here, and you see it's going all the way up to 144. So I could go to the window. I'll start at 0. And let's see, this thing stops at 1, 2, 3, 4, 5. So maybe I'll like go out to 6. And then I said it goes up to 144. So how about I go up to 160 for my y maximum? Now I press graph and I could see all of it. Okay, and the maximum is at t equals 2. See, that's where I hit the high point. Or I could press second trace. Maximum is number 4. And we go before, press enter once. After, you press enter a second time and then a third time. So when x or t is 2, y is 144. But they didn't say how high up does it go. They didn't say what is the maximum height. They said how long does it take. That'd be 2 seconds. Okay, so great. And now, the next phase. So they're asking us for the last part here. State the time interval during which the height of the object decreases. So it decreases the object from 2 to 5 because that's when the graph is dropping. Okay, explain your reasoning. So how do we know this is the answer? All right, that's a good question. So how do we know? Well, we could say, first let's answer it. So from 2 to 5. Okay, and we could say, now once the object reaches maximum height, it begins to fall. Okay, but then we have to say, when does it fall? Until. It doesn't, remember, it doesn't go through the earth. That would be insane. So the object reaches maximum height. It begins to fall until it hits the ground. And when does it hit the ground? It hits the ground at t equals 5 seconds. Okay, until it hits the ground at t equals 5 seconds. Okay, so that would get you full credit here. All right, so you say, that's my interval. How do you know? Because the object starts to fall. After maximum height, it goes up, and then it comes back down, and it falls until it hits the ground. Let me check the... Cool. Alrighty. All right, 34. Oh, this one. Okay. So Fred's teacher gave the class a quadratic function. State 2 different methods Fred could use to solve the equation f of x equals 0. Okay, so it's basically solving a quadratic. Which 2 ways could we use? So, all right, if I had any choice, because then we have to use one, I would say graph it in the calculator. All right, how about I show quadratic formula, though, because that one, like, you probably have to do. So I'll show how to do it. But if I could do it any way I want, I would do graphing. So like I'll say option 1, graphing, then using second trace to see where the graph crosses the x-axis. Okay. And then option 2, like let's say, oh, quadratic formula. Or completing the square if you love completing the square. All right, but I'll use quadratic formula, and then from there, like we'll just solve it out. So quadratic formula is on the reference page, is this one, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So here, I would say, all right, x equals negative, like our a value is 4, b value is 16, c value is 9. So I'd have negative b, so negative 16 plus or minus. The square root of b squared is 16 squared. Minus 4 times a is 4. C is 9. And then all over 2 times a is 4. Okay, and then here, like if you want to show some like in-between work, you know, you can. But let's see. If I go 16 squared, like the inside minus 4 times 4 times 9, that makes 112. Okay, so I could say, all right, x equals negative 16 plus or minus, so I could say plus square root of 112 over 8, and x equals negative 16 minus square root of 112 over 8. Okay, what this means, like plus or minus means you have two answers. Like first you could do plus the radical and then minus the radical. And then I just have to set this up very, very, very carefully in the calculator. Okay, so alpha y equals enter makes a fraction. Negative 16 plus square root of 112 over 8. Okay, and you get, oh, there it is again. All right, but we're going to the nearest tenth, so negative 0.7. Okay, and then here I go minus. So I just press enter to retype it, and then I switch it to subtract, and we get negative 3.3. Okay, so these would be our two answers. If I could do this any way I want, though, once again, then I'm going here, and I'm going to write in the quadratic 4x squared plus 16x plus 9. I press graph. Zoom 6 fixes everything. And see, I have two answers. But I also like to do this. Graph y equals 0. You want to know when is this 0. And then you can just see when does the blue intersect the red. So I press second trace 5 to see the intersection. And I go up to it. And I press enter 3 times. 1, 2, 3. See, I get negative 3.3. Same answer. Okay, second trace 5. I go here, enter, enter, enter. And I get negative 0.7. Okay, but now I actually have to just write the answers out formally. So the negative 16 plus, if I use the quadratic formula, gave me x equals negative 0.7. And then the second one gave me negative 3.3. Okay, so let me just get this. Oh no, it stayed. Okay, let me just fix that, negative 3.3. Okay, so answer 1, answer 2. 4 points. Some schools have gotten like a permit or in a way or pass to use Desmos. Like the schools have to apply for it. So some schools can use Desmos, but you can't just like show up with a Chromebook and be like, hey, I'm here to use Desmos. Like, of course, they're going to deny you. Your school has to apply for it. It's like fairly new schools doing this. All right. So this one, oh, here we go. Linear regression function. Okay, linear regression function. Round all values to the nearest integer. And then correlation coefficient. All right, this is fun. So this is just a lot of typing. So just be ready to type. And remember, for this mode, stats diagnostics has to be on. Stats edit. And now I just type everything in. I press delete to wipe everything out. So 54, 50. All right, you have to watch me type for a little bit. This question is just kind of tedious. As I'm doing it, I'm just thinking to myself, like, please don't make a typo. Please don't make a typo. Because if I were to get something wrong, I'd probably get this wrong. I would make a typo. All right, and then 2,900. 3,080. 2,500. 2,380. 2,200. 2,700. Enter. 3,000. 3,620. And then 3,720. Great. And they match. Yay. Stats, calculate. Linear regression is number 4. All the way through. And you get your A value, coefficient of X, B value, and your R value. This is what we need. Okay, so I'm going to take all of it. Me personally, like, I mean, here you just have to write out the answer correctly. I don't know. I always get in the habit of, like, actually, like, defining this and just saying, like, all right, like, everything to the nearest integer. I guess, no, you know what? Here, you could just write it out. You don't have to say, like, what A and B are. Just, like, show it and say, you know, your linear regression equation for f of t. All right, now one thing. Please don't do this. Don't go, like, y equals negative 58x plus 6182. Like, this would be a real tragedy, okay? This is no good. Like, don't do that. They told us to state the linear regression function f of t. So this is like an I gotcha detail. Like, haha, you have to name it f of t, and it has to be in terms of t, not x. So you have to say negative 58t plus 6,182. All right, that would get you the credit. Fix that. Okay, so just be careful. Those are like details that make you get a 99. Oh, a TI-83, sure, go for it. That's back in my day. If you know how to use it, sure. All right. So let's see. State the correlation coefficient R to the nearest hundredth. So R is negative 0.94 because in the hundredths place is a 4, to the right is a 4, so round down to 0.94. Okay, but negative. Which makes sense because as time goes on, the value is dropping here. But now, does R indicate a strong linear relationship? Yes. I would say R equals negative negative 0.94 indicates, I'm just using their language, indicates a strong linear relationship. Why? This is the theory to know. R is only going to be between two numbers. It's going to go from negative 1 to positive 1. The closer you are to the end, like if you're here or here, this is, you know, very strong. Okay, if it's equal to 1 or negative 1, then it's like a perfect fit. It's like it is a line, basically. 0 is no correlation, but why is this strong? How do we know this indicates a strong linear relationship? The because is, let me just make sure we write relationship. And now because R is very close to negative 1, because R equals negative 0.94 is close to negative 1. Okay, that's how you know. Cool, cool. All right, moving on. Question 36. All right, and then second to last question. We're getting there. All right, just thinking out loud here. Okay, so question 36, 4 points. Yeah, sorry, going through a full Regents. It is pretty tiring at times. I'm trying to explain it, like, you know, very, like, thoroughly, too. I get into detail, so it's, like, you know, informative, too. So people are asking about, like, which tricks. Like, yeah, tricks do get you through the multiple choice and all that, but if you want to just pass, like, tricks will get you by. if you want to do well, like you got to know the theory too. Okay. So yeah. All right. So here, this question is a little wacky. A contractor has 48 meters of fencing that he is going to use. Oh, my last question is a shading inequality. So perfect. We will go over that. So contractor has 48 meters of fencing he's going to use as the perimeter of a rectangular garden. The length of one side of the garden is represented by X, and the area of the garden is 108 square meters. Okay, so the length of one side of the garden is represented by X, and it's in the shape of a rectangle. So I'm just going to go like this and say, like, all right, this is X, and then I'm going to call this one Y and Y. So I just start finding what we know. 48 meters of fencing is going to cover the perimeter. Do you see that? So this tells me, like, oh, perimeter equals 48. And perimeter, you just add everything up. So it'd have, X plus Y equals 48. And if I get 2X plus 2Y equals 48, from here, where I think this is heading is system of equations. Okay, so then let's see. The area of the garden, they told us this. The area of the garden is 108 square meters. So I could say X times Y equals 108. So if I want to solve this equation, I need to solve this one in purple for, let's say I solve for Y. Okay, so maybe I just divide everything by 2 to start. And that tells me X plus Y equals 24. And then subtract X. So Y equals 24 minus X. So this is going to get plugged in over here. Substitution. Okay, so I get X times 24 minus X equals 108. And now quadratic, which we'll solve algebraically. So this makes 24x minus x squared equals 108. And now I can even just go plus x squared on both sides and minus 24x on both sides. So 0 equals x squared minus 24x plus 108. And now from here, if you didn't learn your 18 times tables, I'm sorry. But like, let's say you're like, how do I factor this? You could use the calculator to assist you. So y equals x squared minus 24x plus 108. I do zoom 6, and I'm like, oh no, I only see one of the roots here at x equals 6. So then if I have a root, I just want to point something out, like how, you could think about this. If x equals 6 is a root, that means, let me clean this up. Make this a little neater. All right. If x equals 6 is a root, then the opposite, minus 6, x minus 6 is a factor. Okay, so then I think about it, like which numbers would work. Well, if I have to have one as x minus 6, then the other one would be what makes negative 24 when I, negative 6 plus blank is this, would be negative 18. And if I do negative 6 times negative 18, I get this. I could even go back to the calculator and see that the other root should be at x equals 18. Second graph. And at x equals 18, you see I have my root. So it's definitely working. All right, and then I get two solutions here. This one gives me x equals 6 and x equals 18. But watch what happens. Like if I do a little check here, if I plug in, so this would tell me y equals 24 minus x is 6. I get 18. And you see, like this one would give me y equals 24 minus 18 is 6. So you see, either way, I get these two numbers from my rectangle. I get 6 and 18, or I get 18 and 6. So same result. So the dimensions of the garden, and this is in meters, I would just say the garden. So answer, so like these together tell us the garden is 18 meters. Make that neater. By 6 meters. Like that's the dimensions of the rectangle, 18 by 6. Okay, so that would work. And you could even check 18 plus 18 is 36 plus 6 plus 6 gives us 48. And the product of those gives us 108. All right, last question. Let's see, 6 points. The Real Good Cinema is conducting a mathematical study. In its theater, there are 200 seats. And let's see. So 200 seats. Adult tickets cost $12.50. Child tickets cost $6.25. The goal is to sell this much money worth of tickets. And all right, so adult tickets is going to be X. So adult tickets, X is going to be attached to the $12.50. And then the kid tickets, Y, is going to be attached to $6.25. So here, we have to set up the system of linear inequalities. So here, this phrase, at least, the goal is to sell at least $1,500 worth of tickets. So how much money they generate is going to be $12.50 times X. That's how much money they're going to make from adult tickets. Plus, they're also going to make money from selling the child tickets. It's $6.25 per ticket. So times Y tickets would tell us how much money made. But the goal is to sell at least, which means they need to sell greater than or equal to. All right, at least means the total sales. This is like, representing, and then I'll erase this in a bit. Total sales has to be greater than or equal to 1,500 if we want at least 1,500. If I go less, then I'm not reaching the goal. Okay, so that's how I think my way through that. And let me fix this. Okay, and then next, we have to reread sometimes. Okay, so sometimes in math, like you do all this work and then you forget information they gave you early. You ever get stuck? Remember this phrase. What information did they give me that I didn't use yet? And they said in the theater, there are 200 seats. Well, there's X seats for the adults and there's Y seats for the kids, but the cap is 200. So the number of seats that we could fill, we can't go past 200. So less than or equal to 200. Okay, so this gets things started. And then what we have to do with this on the next page is graph. We have to graph the solution to the system of inequalities and label the solution with an S. All right, so let's go ahead and I'm going to copy and paste this because there's no way I'm going to remember all that. And I will group this, shrink it down a bit. Now for this, what we're going to have to do is solve them for Y. So let's say the first one. First, I'm going to say 6.25y is greater than or equal to, I subtract this on both sides. So minus 12.50x and then the plus 1,500. Okay, so I'm really just once again going minus 1250 on both sides with the x. Minus 12.50x on both sides, and that brings me here. Okay, that's where that line is coming from. And then I divide by 6.25. Now, it doesn't seem like this is going to help, but I promise it will. Okay, these cancel, and I get y is greater than or equal to, these actually, negative 12.50 divided by this is negative 2. So I get negative 2x plus, and just type that in a calculator, 1,500 over 6.25 works out to 240. Okay, so this works out to 240. All right, now once I'm here, so I'm going to move this one over like this. Actually, here, let me try to keep these. Oh, because I grouped those together. Is that why? Let me see. Yeah, those are now joined together. So let me just write the 12.50x. Yeah, you know what? These I'll just rewrite just so it looks cleaner. So here, and that way it doesn't like take over the graph space too. So that's this. And then this one I'll just pretend like is not here. We're going to have this one just minus x on both sides. So now y is less than or equal to negative x plus 200. But here, where my head goes, is slope negative 2. B value of 240. Okay, so now we just go ahead and work through this. So let's see. Starting at 240, that's our y-intercept. And we're going down 2 over 1. Now, you might look at that and be like, wait a minute. Like, we're not going over 1, we're going over 10. You see this, like, scale over here? We're going over 10. So I just want to point out a little side theory, just to note. I could go down 2 over 1, but that's the same thing as going down 20 over 10. Okay, so I'm going to use this one over here. I'm going down 20 over 10. But be mindful, the y-axis is counting by 10. So down 20 over 10 is going to be still going down 2 over 1. Because the x and y-axis, they're counting by 10s. So I just keep doing that. Down 2 over 1, down 2 over 1, like this. Okay, all the way to the end. All right, and then I connect these with a straight line. I would use a student ID or a ruler or something. Don't try to just do this by hand, because if you mess this up, it's like doesn't look so nice. And we're going greater than or equal to. So this is telling us shade above. Okay, so shade above here. I'm going in this direction. Okay, so everything above. Okay, so slope and y-intercept. Being good at the linear stuff definitely helps. Okay, so that's the first one. Label it. All right, I would label this and say, all right, this is, and you could even use the original if you want. The original was, 12.50x, and then plus 6.25y was greater than or equal to 1500. You could use the new one too, but whatever, I'll use the old one. And now the next one is starting at 200. And the slope here is m equals -1, which is -1 over 1, which is the same as saying -10 over 10. So I'm going like down 1 over 1, like this. Till I get here. See, I'm going this way the whole way down. And that should bring me, if I do this right, to 200 on the x. Because I'm starting at 200 and I'm going down 1 over 1. So it should bring me here if we do this right. Let's see, moment of truth. So we're just going. And we're here. And now this, I only have to label one, but if I label the second one, this was y less than or equal to -x plus 200. But originally this was, this one here is just x plus y is less than or equal to 200. Okay, but this is the less than, so this one tells me to shade under. Okay, so this one we're shading under in this space. Okay, so let's go ahead and do that. I'm shading under this line. Okay, so shading under, that means the overlap. Do you see where the overlap is? They told you to label it with an S. So this would be the solution over here. Okay, that would be the solution in this section. So then the second part of this is, so graph the system of inequalities, label the solution with an S, which we did. But now here we go. Marta claims that selling 30 adult tickets, so X equals 30, and 80 child tickets, Y equals 80, will result in meeting the cinema's goal. Okay, meeting the cinema's goal means it's like in the solution set. Okay, that we labeled with an S. Explain whether she is correct or incorrect based on the graph drawn. So here, X is 30, Y is 80. Remember that. X is 30, Y is 80. So is Marta correct? X is 30, Y is 80. No, she's incorrect. So I would say here, no, she's incorrect because 30, 80 does not lie in region S, the solution to the system of inequalities. Okay, so first I'm going to say the question is explain whether she is correct or incorrect. I'll say Marta is incorrect. So Marta is incorrect. Why? Because 30, 80 does not lie in region S. In region S, which region S is the solution to the system of inequalities, if I just borrow that language. Okay, so that's the idea behind this one. All right. So that, yeah, we'll take care of that last question. 6 points if you say all of this. All right. Well, let's see. Oh, wow, 2 hours and 5 minutes in. But what I will say is if you haven't subscribed, and at this point, this stream has been helping, please consider subscribing. It really does help me grow this channel. The algorithm likes to see the subscriber count rolling. It's like, hey, people like this channel. So if it helped, cool. But this does conclude the Regents walkthrough. I did want to end a little earlier today so people have time to like watch or rewatch and then get some rest because the test is early tomorrow. But I just want to say good luck to all of you. And thank you for, coming onto the live stream with me. I know people are nervous. I've been getting those comments a lot. But remember, it's normal to be nervous. That's not something strange. The last time I had to take a serious test, like I do feel those test nerves, but it's like, all right, let's do this thing. Once you get in there, you'll get used to being in the test room. And by the end, you'll be like, oh, just get me out of here. But, just do your best to put the best math that you know down on the paper. And I hope tomorrow you show up, ready and you're able to, get your ideas down. But no matter what, I'm proud that you came onto the live stream to learn more math. A lot of students this time of year, it's really hard to put in any of that extra work. I know it's been a long year, but this is the time that counts the most. When people don't have the energy, is like when you find a way to like put a little more work in to get yourself ready, then great. But, also don't burn yourself out too. Try to go to sleep at a reasonable time and show up ready tomorrow. Okay. So take care, everybody. Yeah. Artemi, I see you there. Good night to you as well, Artemi. And yeah, be well, people. Take care.